Hello, welcome back. The title of this lesson is Finding Sine, Cosine, Tangent with the Unit Circle in Radians. This is part one. So here we put all of the skills together. We have introduced the unit circle in degrees. We just now in the last lesson then introduced the unit circle in radian measures. We now know all about radians. And now we need to go and learn how to calculate the sine, the cosine, the tangent, also the other trig functions, the cotangent, the secant, the cosecant, with any angle in any quadrant of the unit circle. So it gets tricky in radians because we're not comfortable yet with radians. So here's how we're going to do this. We're going to look at the unit circle really quickly, refamiliarize ourselves with it, and then as we solve the problems, I'm going to try not to use the unit circle too much. We will use it. I will bounce back and forth between using it and not using it so that you can kind of check yourself and make sure that you understand. But I really do want to show you how to solve these problems without using the crutch of the unit circle. It is important to use it, but it isn't important to use it for every single problem. So the process will work like this for every problem. We're going to identify where the angle is in radians. That's going to be given to you. And then we have to go figure out what quadrant that's in. And we're going to do that by counting around the unit circle and figuring out where our angle is. Once we know where the angle is, then we will then go figure out the reference angle, the angle between that ray and the nearest x-axis. Because the sine and the cosine is all going to be dependent upon what the angle is between the ray that we have, the angle that we have, and the nearest x-axis. So once we have the sine or the cosine or whatever we're trying to find from quadrant 1, from that reference angle as if it were in quadrant 1, then we will just apply signs, either negative or positive, to the answer. So I know it sounds really complicated, but it's the same exact process we used in degrees. Now we have the extra wrinkle of having to deal with it in radians. So here's the unit circle in radians in all of its glory. We've already gone over this extensively in the last lesson, so I'm not going to review all of it again. What I want to focus your attention on is quadrant 1 right here. We have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. The quadrant 1 is the most important quadrant. Everything else comes from quadrant 1. What you need to really remember is that over here at the 0 degree line, it's 0 radians. The 30 degree line is pi over 6. 45 degrees, pi over 4, 60 degrees, pi over 3, and 90 degrees, pi over 2. We already went through in the last lesson good ways to remember that, so I'm not going to review it all again. But basically, we need to remember these guys so that when we go in other quadrants of the unit circle, we can easily count and figure out where they are. Now, it's going to be much, much easier to do this by solving a problem. So let's say we want to now tell me what the sine of pi over 4 is. Now, when you see sine of pi over 4, there's no degree symbol or anything, and it involves pi, then you automatically know it's radians. You know, when you first learn math and trig, you work in degrees a lot, and everybody's comfortable with degrees. But very soon, when you go up in math, you get away from degrees, and really you kind of start assuming things are not in degrees anymore. Most math beyond basic triangles and things like this really aren't working in degrees anymore. So all of these, especially if you see a pi involved, they're always going to be radian measure. All right? So what is the sine of pi over 4? How do we do this? The way you do it is, you remember, pi over 4 is the only one of those angles that has a 4 in the bottom. And that means it's 45 degrees. That's how you remember it. The pi over 4 means it's a 45 degree angle. And we know that a 45 degree angle is in quadrant 1 in our memory. So if we were to kind of sketch this thing, which we do want to do, I think, for every problem, even if it's just a simple little sketch, we don't have to label anything. We know that this pi over 4 angle is basically going to be at a 45 degree line. I know that may not be exactly right, but it's basically a pi over 4 is the angle, or you could say 45 degrees to help you remember it. And we should remember from the unit circle that 45 degrees, the sine and the cosine is the same number. It's the square root of 2 over 2. So there's no mental gymnastics we need to do. The sine of pi over 4 is just simply going to be the square root of 2 over 2 because it's exactly the same thing as the sine of 45 degrees. So let's go off to the unit circle and verify that. 45 degrees is right here on the diagonal between 0 and 90. The cosine of this angle is square root of 2 over 2, and the sine of this angle is also square root of 2 over 2 because the projection on x is down here, which is exactly the same as the projection on y by exactly that number, square root of 2 over 2. So that's the first problem. For every problem, we're going to do it like this. We're going to sketch where it is here in the beginning, and then after a while, you probably won't have to sketch every problem, but in the beginning, we definitely want to. So 3 pi over 4. So this is where the wheels come off the train a lot of times. Students will try to look at this and see this and look at this and just try to guess the answer. You can't do that. You have to know what quadrant your angle is in and know exactly in your mind where it's at. And you need to draw a little sketch because everybody makes mistakes. We all want to make sure that we have, you know, the correct quadrant here. So let's look and see how we would count through it. All right, so if we know this is 0 and we know this is 90 degrees, so we know that right here between must be pi over 4. And then just like we learned in the last section, counting by pi over 4 segments means this is pi over 4, this is then 2 pi over 4, and then this is 3 pi over 4. So 3 pi over 4 is the angle that we want to find, and we know then it must be at this angle right here. So this angle is actually 3 pi over 4. Again, that's pi over 4, 2 pi over 4. 2 pi over 4, remember, reduces to pi over 2. Then we have 3 pi over 4, which lands here. So here's what you do. You know that this is in quadrant number 2, and you say, what's the reference angle between this ray and this axis? Now, because you've drawn it and you know you're counting by 45 degrees, the angle between here and here is just another 45-degree angle or another pi over 4 radians. So really what you have to do is ask yourself, okay, if the reference angle is pi over 4 or 45 degrees, what's the sine of that? Sine of pi over 4. We just did that in the previous problem. The answer to that was the square root of 2 over 2. Now we have to ask ourselves, should we put a negative sign or leave it as positive? You look in this quadrant and its projection onto the y-axis would be a positive number, so this should be a positive number as well. So the actual answer is the positive square root of 2 over 2. You notice how we didn't have to use the unit circle. We just know that the sine of pi over 4 is square root of 2 over 2, and then we look at the quadrant we're in to see if it should be positive or negative. But as a check, we go here and say this is pi over 4, 2 pi over 4, 3 pi over 4. The sine of 3 pi over 4 is positive, notice, positive square root of 2 over 2, because the projection goes to the positive y-axis right there. All right, so let's crank up the complexity a little bit. I think a lot of students can get that without any problem. And this next problem is not difficult, but we want to make sure we can do problems of all types. So what if you had the sine of negative 3 pi over 4? And again, a lot of students, you know, when you start learning this stuff, you don't know quite what to do if it's negative 3 pi over 4. So let me write a pi correctly here. So there's a pi like this. All right, so again, it all boils down to drawing a picture. Do not try to do this kind of stuff in your mind. You can, you know, look at the unit circle, that's fine, but I'm trying to teach you how to do things so you understand it. So if this is 0 and you're going negative angles, you have to count in chunks of pi over 4. So here's 1 pi over 4, negative 1 pi over 4. Here's negative 2 pi over 4. Here's negative 3 pi over 4. So we now know it's right over there. So we'll draw a little ray out at a 45-degree little angle right there. This is negative 3 pi over 4 as far as its angle measure, like this. That's its angle measure. This angle measure was measured this way, so it was positive, and that one was measured there because it was positive. So negative 3 pi over 4. So then we ask ourselves, what is the reference angle? I mean, it's obvious. We're counting in chunks of pi over 4, 45 degrees. So the angle between this and the nearest x-axis is 45 degrees. So the actual sine of this thing, the number is going to be the sine of 45 degrees, or the sine of pi over 4. It's the same number as all the other problems. It's the square root of 2 over 2. But then we have to ask ourselves, is this, should be left positive or should we make it negative? So we look at this quadrant and we say the projection onto the y-axis, because it's a sine, is going to be on the negative y-axis. So actually the projection here is negative square root of 2 over 2. You see, basically, since we know the ray is here, the projection has to be a negative square root of 2 over 2. The projection here is on the positive y-axis, so it has to be positive square root of 2 over 2. And the projection here is on the positive y-axis, positive square root of 2 over 2. In all three cases, it's the same number, square root of 2 over 2, because this thing is, relatively speaking, at a 45-degree angle all over the unit circle. So the projection here and the projection here and the projection here is always square root of 2 over 2. That's why we use the reference angle to figure out what the number is. But we have to look at the quadrant to figure out if it's going to project onto a negative or a positive axis. So let's check ourselves. Negative 3 pi over 4, the sine of that being negative square root of 2 over 2. You look at your unit circle, and you realize, oh no, I don't have any negative angles on the unit circle. I can't check myself. This is why using the unit circle is great in the beginning, but it limits you. If you're just using it to just get your answers, then you can't do anything beyond a really basic problem because there's no negative angles here. And if you don't know how to count by pi over 4 chunks in the negative direction, you'll never know what to do because all of these angles are positive, right? So what you do is you say, well, okay, I know how to count, right? So here is actually, even though it says 7 pi over 4, this is really negative pi over 4. And this is really negative 2 pi over 4. And this is really negative 3 pi over 4 because it turns out that negative 3 pi over 4 is exactly the same as positive 5 pi over 4. Same angle in the same quadrant, just expressed differently, right? And that's the way it goes, like fractions. You know, 1/2 is the same as 5/10. They look different, but they represent the same thing. So negative angles and positive angles can represent the same thing. If you don't know how the unit circle is laid out and you're just randomly doing problems, then you know, you're going to end up getting into trouble with any kind of thing more complicated. All right, so let's take a look at tangent of 5 pi over 4. All right, now again, you notice that there is no tangent on the boundaries of the unit circle. So what you do is you say the tangent can be written always as the sine of the angle divided by the cosine of the angle. So this is the way you do it. You literally write the sine of 5 pi over 4, and you divide whatever you get there by the cosine of 5 pi over 4, like this. So now it reduces to figuring out what the sine of this angle and what the cosine of this angle is. So the next step is really to take a look at what quadrant this is in because it's going to determine everything else. Notice it does have a 4 on the bottom, so we know it's going to be some 45-degree angle somewhere here. So let's count. Let's figure out where it is. Here's 0. Here's pi over 4, 1 pi over 4, 2 pi over 4s, 3 pi over 4s, 4 pi over 4s, 5 pi over 4s. So 5 pi over 4 is going to be at this kind of this 45-degree angle between these two axes right here, 5 pi over 4. It's a positive angle, so it's measured like this. That's the angle, 5 pi over 4. So then we have to ask ourselves, what is the reference angle to figure out what the sine and cosine is? Well, it's easy in this case. This is a 45-degree angle, the reference angle to the nearest x-axis. So we're basically trying to find the sine and the cosine of pi over 4, the reference angle, which we already know is the square root of 2 over 2. So what we do is we say, well, on the top is going to be the number is going to be the sine of this pi over 4, square root of 2 over 2. And on the bottom, it's also going to be square root of 2 over 2. And now we need to put the correct signs in place. So here's the sine of this angle. We know the number is square root of 2 over 2, and it's projecting onto the negative y-axis, so this has to be negative. The cosine of 5 pi over 4 means this is projecting up to the negative x-axis, so in this quadrant, the cosine is going to be negative 2. So what we figured out is that the sine of 5 pi over 4 is actually negative square root of 2 over 2. The number, square root of 2 over 2, comes from the fact that we're just, essentially, we're taking the sine of the reference angle, and then we stick a negative on because it's projecting down here. Here, same reference angle, so the cosine is the same number, and then we're projecting to the negative axis, so we get a negative. But negative divided by negative gives us a positive, so actually this divided by this is just a positive 1. That's the tangent of 5 pi over 4. Go into a calculator and calculate the tangent of 5 pi over 4 or a computer, and you'll see that the answer is positive 1. So let's check ourselves. So here was pi over 4. Pi over 4, 2 pi over 4 reduces to this. 3 pi over 4, 4 pi over 4 reduces to this. 5 pi over 4 is right exactly where we said. The cosine of 5 pi over 4 is negative square root of 2 over 2, and the sine of 5 pi over 4 is also negative square root of 2 over 2. So sine divided by cosine is going to be this number divided by this number. It gives you a positive 1. It's exactly what we have said. So I think what I can do actually is just drag this board over here so I can leave my unit circle kind of out. All right, and this process we're going to continue. Let's do something that looks difficult, you know, and shuts a lot of students down, but it's not that hard. What about the secant of 3 pi over 2? 3 pi over 2. Well, first of all, you know, when you see secant, a lot of people don't like, what is that? So here's what you do. You go off to the side and you say, well, this is how I write them down. Sine, cosine, tangent. Then after that comes the cotangent, then the secant, then the cosecant. You just have to remember the order. This one goes with this one, this one goes with this one, this one goes to this one. So the secant, this guy, is actually 1 over the cosine. So 1 over the cosine of what? 3 pi over 2. So this whole problem reduces to figuring out what the cosine of that angle is. So the next thing we have to do is we need to draw a sketch on the xy plane of where that angle actually is. Now before, we had a 4 in the denominator, but we don't have that anymore. So when we had a 4 in the denominator, we knew we had to count in chunks of pi over 4. So now that the angle does not have a 4, it has a 2 in the bottom, we know we're going to have to count in chunks of pi over 2. And you should remember, I told you had to remember a couple things. Pi over 2 is just the vertical y-axis. So what we're going to do is say, okay, here's 0, here's 1 pi over 2, then again counting in chunks of 90 degrees, there's 2 pi over 2, then here's 3 pi over 2. We never had to look at a unit circle to know that this angle was 3 pi over 2. So basically it's this angle down here. I guess I can try to do it in red to kind of show you. I'll draw the line like right next to the axis, but it's really on top of the axis. This is the angle right here, is 3 pi over 2. So it's pointing straight down like this. So let me ask you a question. I'm trying to find the cosine of this angle. I have to put a 1 on the top, of course, and I have to find the cosine of this angle. All right, cosine is the projection of an angle onto the x-axis, okay? So if I'm shining a light, trying to project this thing onto the x-axis, what am I going to get? No projection at all. So the cosine of 3 pi over 2 actually turns out to be what? 0. There is no projection. So I'll put a 0 here. Now what is 1 over 0? You can write undefined if you want, but I generally like to write infinity. So you can say infinity or undefined. Because really both answers I would consider to be correct. What's going to happen when we graph the secant function later on and also the tangent function, we're going to find that because the tangent is sine over cosine, because the secant is 1 over something, all of these trig functions with a fraction with something in the bottom, there's always going to be some angle that will go to make this thing go to 0, and so you'll get an infinity somewhere. So when we graph these later on, we'll see these things shoot up to infinity at certain angles. And this is one of those angles. At 3 pi over 2, you get an infinity in the secant curve, or you can just call it undefined if you want to. Basically, if you get really close to 3 pi over 2, it shoots up or shoots down negative depending on which way you're going, but it's going to infinity one way or another. All right, how would you check this? Well, the unit circle doesn't have anything to do with secant, but we can certainly see that here's pi over 2, there's pi over 2, there's 2 pi over 2 that reduces to this, 3 pi over 2 right here, and we were trying to find the cosine. So the cosine of this is 0. That's the first number. And so 0, we can check that part in the unit circle. 1 over 0 gives you infinity. All right. So let's check the next guy. Let's take a look at something very similar. What about the cosecant of 3 pi over 2? So it's almost exactly the same thing. It's the same angle, but a different trig function. What is the cosecant? It's 1 over the sine. 1 over the sine of 3 pi over 2. So we don't have to draw a figure again, it's right here. So let's say we want to find the sine of this angle. The sine of this angle. The sine is the projection onto the y-axis. It's a unit circle. So this problem boils down to figuring out what the sine of 3 pi over 2 is. So we don't need a new figure. We have one right here. The figure shows 3 pi over 2 down here. And the sine is the projection of this onto the y-axis. So what would the projection of this on the y-axis be? Well, the entire kind of hypotenuse or ray lies on the y-axis, so all of the projection goes on the y-axis here. So what would the projection actually be? Well, you have a 1 in the numerator here. The sine of this angle, the projection, look, it's on the negative y-axis. Down here is going to be a -1. So when you look at the projection, you're not just looking for the number, you're looking for the actual sine of it, not the sine or cosine, I mean the plus or minus, the negative or positive sine of it. This is going to be projection onto the y-axis because it lies on the negative y-axis, and so it has to be -1 down here. So when you divide this, what do you get? -1. So the cosecant of this angle turned out to be -1, while the secant of the same angle turned out to be infinity or undefined. Now again, you can't check this too much just using the unit circle, but you can go down to 3 pi over 2 down here and see that the sine of this angle is actually -1, so that's what we put in there. So you see, the unit circle is useful. I mean, I can come down here and say, oh yeah, the sine's -1. you can use it, but the problem is it becomes too much of a crutch. If you don't even know the basic ones, like 3 pi over 2 being down here and the sine of it being -1, then you're going to use it as so much of a crutch that you're not going to really understand what you're doing. And anything more advanced, which we will get to things more advanced, you'll have a hard time with. But you see the way we did this, we didn't even use the unit circle. We just said, we're going to count by pi over 2's. There's 1, there's 2, there's 3 pi over 2. It's down here. Okay, the sine of that angle has to be -1 because it's down here. And so we got the entire solution without even looking at the unit circle. And that's what I'm trying to teach you. All right, so let's see if we can do the same thing. We did the secant of this angle, we did the cosecant of this angle, and just for giggles, let's do the tangent of, well, I was going to say of the same angle, but actually no, it's a different angle, 2 pi. Let's do the tangent of 2 pi over 3. So remember, the tangent is always written as the sine over the cosine. So it's really the sine of 2 pi over 3 divided by the cosine of 2 pi over 3, like this. Tangent of 2 pi over 3. All right, so then what do we have to do? Obviously, we have to know where is 2 pi over 3 in the unit circle. You can look at the unit circle. There's nothing wrong with that, but it kind of robs you of the ability to visualize things. So let's do it ourselves. We need to count in chunks of pi over 3. What is a chunk of pi over 3? Remember, with a 3 on the bottom, that's a 60-degree angle. If it was a chunk of pi over 6, that would be a 30-degree angle. It goes with the opposite number. So a pi over 6 is actually a 30-degree angle. A pi over 3, with a 3 on the bottom, is a 60-degree angle. This is 90, so 60 degrees is about like this. So we need to count in chunks of 60 degrees. So there is 1 pi over 3. Then another 60 degrees would be 2 pi over 3. And then 3 pi over 3 would be here, but 3 pi over 3 is pi. That makes sense. So let's do it again. There's 1 pi over 3, there's 2 pi over 3. That's the answer. That's what we're trying to find. So then we just now draw our picture and say it's up here. The angle here is 2 pi over 3. Again, 3 pi over 3 would be here, and then 4 pi over 3 would be here, and then 5 pi over 3 would be here, and then 6 pi over 3 would be here. What is 6 pi over 3? It's 2 pi. That's why you get back into the circle. So this is where the angle is. So the next question you ask yourself is, because I need to know the sine and the cosine of this thing, is what is the reference angle? Well, since I know that it was 60-degree chunks and I know that I landed here, then the reference angle is 60 degrees. 60 degrees. You could say it's pi over 3, but it's basically 60 degrees. So we need to know, as far as the numbers up here, what is the sine of 60 degrees and what's the cosine of 60 degrees? That's what I want to do. So in the top, what would be the sine of 60 degrees? Well, I know the sine of 30 is 1/2, so the sine of 60 is the other number. It has to be the square root of 3 over 2. And then I say, well, is the projection, is the sine of it correct? It's going to project onto the positive y-axis, so it should be a positive, so that's correct. What is the cosine of essentially the reference angle, 60-degree angle, right? The cosine of 60 is going to be 1/2, right? How do I know it's 1/2? Well, you kind of get familiar with these things after a while, and you realize that if the sine of 30 is 1/2, then the cosine of the other angle, 60 degrees, is also 1/2. Those are things you have to work through to start to remember, but the answer is 1/2. But is the numerical sign of it correct? This thing is going to project onto the negative x-axis, so actually it has to have a negative sign. You see, it's easy to get these numbers, but if you get the signs wrong, the whole thing is wrong. So in this quadrant, it makes sense. The sine is positive and the cosine is negative. Sine is positive, cosine is negative. So then what do we get? Let me just catch up to myself here. We have this guy. So we have the square root of 3 over 2, and we're going to multiply, change this to multiplication, and flip -2 over 1. And then you see the 2's are going to cancel. I guess I'll just strike through them right here. So what do we actually get? Negative times square root of 3. And so the answer, let me just double check myself. Yeah, negative square root of 3. So the answer to the tangent of 2 pi over 3 is negative square root of 3. Now I grant you, we had to do some mental gymnastics to figure out what the sine and cosine of those angles are, but I'm trying to teach you by doing how you would go about doing it. Let's check ourselves. The tangent is not written on the unit circle, but we can certainly check and see, is this angle correct? It is 2 pi over 3, pi over 3, 2 pi over 3. Okay, this is all correct. The sine of that is this number, positive square root of 3 over 2. That's what we wrote down here. And the cosine of this is the first guy, the projection onto x, which was negative 1/2. Project onto negative axis, project onto positive y-axis, project onto negative x-axis. So What you do to find the tangent is sine over cosine. This divided by this, which is exactly what we did. This divided by this, we do the math, we get negative square root of 3. That's the final answer. All right, we're going to do one more in this lesson, and then we'll wrap it up and do some more problems in subsequent lessons. Let's find something that looks really crazy. Cotangent of 11 pi over 6. Looks really difficult, right? Well, first of all, what is the cotangent? You can go over here and you realize the cotangent is 1 over the tangent. So really, it's 1 over the tangent of 11 pi over 6. Now, you can certainly do the tangent like this, but really what I like to do is say, well, this is really 1 over, this is the sine of 11 pi over 6 over the cosine of 11 pi over 6. But that's all in the denominator there. So when I actually do the division, I flip and multiply. Really, the cotangent is equal to the cosine of 11 pi over 6, all divided by the sine of 11 pi over 6. Now, I probably won't do this too much in the future, but basically, you know that tangent is sine over cosine. Cotangent always works out to be cosine over sine. That's what you should really remember. But the way you get there is you say, oh, it's 1 over tangent, 1 over sine over cosine, flip and multiply. But really, going forward, tangent is sine over cosine. Cotangent is cosine over sine. That's how you should remember it. So we need the cosine and the sine of this angle. So we need to figure out where this angle is to figure it out. So here's the xy axis, and we need to count in chunks of pi over 6. What is a chunk of pi over 6? That's a 30-degree chunk. What does a 30-degree chunk look like? This is 90, so 30 is down here. And we need 11 of these chunks. So here we go. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Notice 6 pi over 6 comes out to pi. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. So it's 11 pi over 6. It looks something like this. 11 pi over 6, and the angle is measured all the way around like this. Notice if I had gone one more step to 12 pi over 6, 12 over 6 is 2, so that would be 2 pi, so I would get right back around where I started. So I'm very confident that this is the correct number. And since I'm counting in chunks of 30 degrees, I can know from the drawing that this reference angle has to be 30 degrees because I started at a 30-degree angle counting around. And so when I get here, I know that this reference angle is 30 degrees. So this whole thing boils down to figuring out what is the cosine of that reference angle, 30 degrees, and put the correct signs on it, and then the sine of 30 degrees in all of this, right? So what is the cosine of 30 degrees? What is the cosine of 30 degrees? Well, the cosine of 30 degrees is the square root of 3 over 2. And you can go through the mental gyration. Sine of 30 is 1/2, so the cosine of 30 must be the other angle. Now let's check the signs. Down here, it's projecting onto the positive x-axis, so this should be positive, so I'll leave that alone. What is the sine of the reference angle? The sine of the reference angle being 30 degrees. Sine of 30, we've been saying, is 1/2 all along, but the projection will actually land on the negative y-axis. So actually, this will be negative 1/2 down here. Okay, negative 1/2. So you have positive square root of 3 over 2 over negative 1/2. So all we have to do is crank through that. Square root of 3 over 2 multiplied, flip over here, it'll be negative 2 over 1. And so what do we get? We get a cancellation here, and so we get negative square root of 3. So actually, we get exactly the same answer. Let me just double check. We get exactly the same answer as we got before. So it turns out that the tangent of this angle, which is way far away, is exactly the same thing as the cotangent of this other angle, which is way far away from this guy. And you cannot predict ahead of time unless you're a human calculator how to do that. But what we can do is we can say we figured out the angle was over here about 30 degrees, exactly 30 degrees from the x-axis. 11 pi over 6 is right here, exactly where we predicted. Pi over 6, 2 pi over 6 reduces to this. 3 pi over 6 reduces to this. 4 pi over 6 reduces to this. 5 pi over 6 is here. 6 pi over 6 reduces to this. 7 pi over 6. 8 pi over 6 reduces to this. 9 pi over 6 reduces to this. 10 pi over 6 reduces to this. 11 pi over 6 reduces to is this. And then 12 pi over 6 would go there. So here we are. And then it was cosine divided by sine. Cosine divided by sine. So positive square root of 3 over 2, negative 1/2. Positive square root of 3 over 2, negative 1/2. Divide, this is the answer that you get. Believe me, I know. when you learn this the first time, it's kind of overwhelming. There's a huge circle here, a huge unit circle with degree markings and radian markings and crazy square roots that go all the way around. My experience is that it seems really hard if you try to jump into these problems without understanding really what you're doing, because then it seems like you're just given like an incomprehensible thing and you just have to go and figure it out and just kind of you're guessing and feeling. You can't do that. Every problem you have to say, what am I counting by? What quadrant am I in? How far away in degrees am I from the x-axis, the reference angle, so that I can figure out what the sine and cosine are, and then I got to put the signs on there at the end. That whole process, I'm not dumbing it down for you. I'm not doing it like that for you because you're just learning. That's exactly how I do it. If I show you my paper, that's how I'm working through every one of these. So I'm not doing anything on my own paper different than I would do or tell you to do. So what I want you to do is solve all of these yourself. Maybe watch it a few times if any of these seem you're unsure of them. And then follow me on to the next lesson. We're going to get a lot more practice with this because it really is one of the most important skills. So do these, follow me on. Let's get more practice with finding sine, cosine, tangent using radian measurement in the unit circle.